Well, we are still on chapter 7. We're going to continue introducing different methods and techniques of taking integrals. So far, we talked about different methods. We had some formulas. Following those formulas, then we said that what if we have some square root of x squared minus a squared, or a squared minus x squared, or x squared plus a squared? Remember, we introduced the trig substitution. Well, today we're going to talk about partial fractions. Suppose you have an integral like this. So this is our example. We're going to start by writing this example here. We have x cubed plus x divided by x minus 1 dx. How do we find this integral? Well, one way is saying that we have an expression on the numerator and the exponent is 3. The exponent is larger than the power or exponent of the denominator. So here we can use long division. Okay. If we do long division, let's see what do we have. So let us divide. We have x cubed plus x and x minus 1. Very well. Our very first term is going to be x squared. We get x cubed minus x squared. We subtract these two. So it means that we can get rid of x cubed and its opposite. We're left with x squared plus x. So the very next term is going to be x times x squared minus x. What's left? If we subtract these two, we get 2x. Then we're left with just a scalar number 2. 2 times x minus 2. We subtract these two, we get positive 2. So what's the meaning of that? It means that x squared plus x plus 2 is equal to, sorry, not this guy, x cubed plus x is equal to the product of x minus 1 times x squared plus x plus 2 plus the denominator, which is just 2. So we can break down x cubed plus x into the product of x minus 1, x squared plus x plus 2, plus its remainder, which is 2. So this integral can be written as the integral of x minus 1 times x squared plus x plus 2 plus the remainder 2. Everything is divided by x minus 1 dx. Our numerator, x cubed plus x, is now this expression plus a constant 2. This is this guy. Using the same color, so you see how we broke this down. Well, okay. Now let us do the division here between these two fractions. It's going to be the integral of x minus 1 times x squared plus x plus 2 divided by x minus 1 plus 2 over x minus 1 dx. So obviously, we can cancel out x minus 1 and x minus 1. These two are common factor. So we're left with the integral of x squared plus x plus 2 plus 2 over x minus 1 dx. We already know how to find these two integrals. This is going to be x cubed over 3 plus x squared over 2 plus 2x plus 2 times ln of absolute value of x minus 1 plus constant of integration. Recall that the integral of x to the n dx is x to n plus 1 over n plus 1 plus c, and the integral of 1 over x minus 1 dx is ln of absolute value of x minus 1 plus c. You're using these two main formulas to evaluate the rest of the integral. So note that when we have a higher exponent, higher power on the numerator, you're allowed to do the long division, break down the integral into smaller pieces, simpler format, so we can easily calculate the integral. What if the denominator has the larger power? For example, what if we have this type of integral? Take a look at this case. Here we have the integral of, this is our example. Question says, evaluate the integral x squared minus 2x plus 1 divided by, this is a minus 1, make sure I'm following. The example, 2x cubed plus 3x squared minus 2x. Minus 2x. So first of all, note that the exponent, the power of the denominator is 3, and the power of the numerator is 2. So we can say that the degree of the denominator is larger than the degree of the numerator. When it comes to cases like this, we need to break down, factor out the denominator. So step 1, factor the denominator. Okay, let's factor out our denominator. Here we have 2x cubed plus 3x squared minus 2x. We can factor out x. We get 2x squared plus 3x minus 2. Here you have a quadratic expression, and you can break this guy down more into x times x plus 2 and 2x minus 1. There you go. This is our very first step. We have 3 expressions, and they are all in linear form. The exponent of x is 1. The exponent of x is 1. The exponent of x is 1. So here you have 3 linear expressions. Linear expressions. When we have linear expressions, we can use partial fractions as follows. So set up partial fractions. The setup is So you take the original quotient, the fraction that you have, x squared minus 2x minus 1 divided by 2x cubed plus 3x squared minus 2x. You set it equals to the sum of three fractions with these denominators. The very first linear expression is going to be your first denominator, your second denominator, and your third denominator. The order is not important. The first fraction plus the second fraction plus the third fraction. So this is your x, then x plus 2, then 2x minus 1. But what is the numerator? The first numerator, the second numerator, and the third numerator. So what are those? Do we have any idea? No, we don't know that. And our goal is to find those numerators. Very well. Since you have linear expressions without repeating exponents, these expressions, linear expressions, are separated from each other. So the way that you set your numerators, it means that you're dealing with some constants. A is a number, B is another number, and C is the third number. We don't know what they are. Our goal is to solve this equation. Solve this equation to find A, B, C. To find A, B, and C. So how do we solve this equation? I'm going to write that on the left-hand side. I need more space. If you multiply these denominators together, you get the denominator on the left-hand side, or the original denominator. Okay, so what's the common denominator, least common denominator for these three factors? For these three factors, the least common denominator is the multiplication. So what's the meaning of that? If I combine these three fractions, it's going to be A times x plus 2 times 2x minus 1 plus B times x times 2x minus 1 plus C times x plus 2. And my denominator is going to be the same as this denominator, or just the multiplication of x plus 2, 2x minus 1. These are all the same. Okay, so what's the use of this? I already know that these denominators, they're all the same. They're the same thing, the multiplication. How about the numerators? You have two fractions, they are equal to each other. Denominators are the same, so it means that your numerators must be the same. Okay, what's the meaning of that? It means that if I just multiply these, distribute A, B, and C, this expression here must be x squared minus 2x minus 1. So let us start multiplying these and see how we can simplify this. We have A times, we get 2x squared minus x plus 4x minus 2 plus b times 2x squared minus bx then here we have plus cx squared times 2cx squared plus 2cx. Your denominator stays the same, or you can write it like this. It doesn't matter. X times x plus 2 times 2x minus 1. So here you have 3x. Let us distribute a into parentheses. And minus 2, 2x squared a. Three ax minus 2a. Okay, very well. So what's the next step? I already know that these denominators are the same. These denominators are all the same. The numerators must be the same. Well, okay. Numerators must be the same. It means that 2x squared, let me erase this part. Two x squared times a plus 3ax or 3xa minus 2a plus 2x squared b minus bx plus cx squared plus 2cx. This is equal to your numerator, which is x squared minus 2x minus 1. Plus 2x minus 1. Okay, very well. Take a look at your quadratic terms. X squared, and x squared. So if you take out x squared, you get x squared, 2a plus 2b plus 2b plus c. This is equal to x squared. Plus. Then let us take a look at our linear terms. This term here, and also this term. So let's see if we factor out x, we get 3a minus b plus 2c. Minus b plus 2c. And finally, we have a constant, which is negative 2a. Negative 2a. These two quadratic expressions must be the same. So let us start solve this system of equations. System of equations. Note that here you have x squared, which is multiplied by 1. 1 times x squared. Here you have 2x plus negative 1. Plus negative. So two quadratic expressions are the same. It means that, okay, x squared and x squared are the same. Their coefficients must be the same as well. 2a plus 2b plus c is 1. And then the second equation, x and x, they are the same variable. The coefficient for x is 2, but the coefficient for this x is dependent on a, b, and c. These are just numbers. So it means that this expression is equal to 2. 3a minus b plus 2c is equal to 2. A minus b, 2c is 2. And finally, the constants. The constant in the quadratic expression is negative 1. The constant in the second quadratic expression is minus 2a. So what's the meaning of that? It means that minus 2a and negative 1 are the same thing. Okay, this is what we learned in intermediate algebra. To solve this system of linear equations in 3 variables, first of all, we can use the last equation to find a. By using the last equation, a is equal to a half. You easily found your a. Very well. So how do we find b? How do we find c? We need to distribute, we need to substitute a into 1 and b, and then use methods that we learned in intermediate algebra to find b and c. So let's do the substitution. Here we get 1 plus 2b plus c equals to 1. And substituting that for the second equation, it gives us 3 halves. 3 halves minus b plus 2c equals to 2. Okay, well, we have more work to do. So the first equation becomes 2b plus c equal to 0. It means that c is equal to minus 2b. And here, the second equation, you have negative b plus 2c equals to 2 minus 3 halves, which is just a half. And then we can substitute c here and solve for b. So minus b. And here negative 4b is a half, so minus 5b is a half, and b is negative 1 over 10. Since b is negative 1 over 10, c is going to be a fifth. So we found our a, b, and c. So take a look at this. We start breaking down x squared plus 2x minus 1 divided by 2x cubed plus 3x squared minus 2x as a over x plus b over, it is x plus 2 plus c over 2x minus 1. Then we said that this is equal to a times x plus 2 times 2x minus 1 plus b times x 2x minus 1 plus c times x plus 2 divided by x times x plus 2 times 2x minus 1. Then we distributed a into parentheses, b into parentheses, c into parentheses, and we set these to equal to each other. So a times x squared to x squared minus x plus 4x plus 3x minus 2 plus b times 2x squared minus x plus c times x squared plus 2x. This is equal to x squared plus 2x minus 1. It means that here we have 2a plus 2b plus c times x squared plus 3a minus b plus 2c x, and here minus 2a is equal to x squared plus 2x minus 1. So it means that 2a plus 2b plus 2c is equal to 1. 3a minus b plus 2c is equal to 2. And your constant, which is minus 2a, is equal to the constant on the right-hand side, negative 1. We set this up this way. So we have 2a plus 2b plus c equals to 1. 3a minus b plus 2c is equal to 2, and then negative 2a equals to negative 1. By solving the last line, a is a half, then we did substitute a into equation 1 and 2 and solve for b and c. So our b is equal to negative a tenth, and c is 1/5. So that's how we calculate a, b, and c. So now we need to substitute these partial fractions for that original fraction here. So this guy is equal to the integral. Well, our a is a half, so we get a half divided by x. Our b is negative a tenth plus negative 1/10 divided by x plus 2 plus our c is a fifth divided by our last denominator, which is 2x minus 1 dx. We can break down each of these integrals into a half integral of dx over x minus a tenth integral of dx over x plus 2 plus a fifth integral of dx over 2x minus 1 can easily solve each of these integrals. This is a half ln of absolute value of x minus a tenth ln of absolute value of x plus 2 plus. So here you can use substitution 1/10 ln of absolute value of 2x minus 1 plus constant of integration. Well, suppose we have this case here. Suppose I ask you to evaluate this integral.